Precalc, Chapter 3.2. We're going to start off with dividing polynomials today, and that's all we're going to do. You guys should have done this in geotrig. I actually am doing that right now with my geotrig kids. So, same exact steps that I gave them, I'm giving to you. And the first thing you need to do, and I'm going to go through all the steps first. It may not make much sense at first because there's just a bunch of words until we get into a problem. But put the polynomials in the standard form. Highest to lowest power. Both the one you're being divided by and the one that you're dividing into. Okay? Then, if there are things missing in the one that is being divided, so it goes from, say, an x to the fourth power to an x squared power, that means you're missing x cubes. If the one you're being divided into is missing those, you need to have what we call placeholders. You need to put a 0 x cubed. You need to have all of the x powers from the highest all the way down to the constant. So if there's no constant, a plus 2 or a minus 3 at the end, you also need a 0 there. You need to have one. This allows me to set up columns for every type of degree. So then you set up your division. Everything needs to have its own column. That's what I just said. Which means the number you're dividing by goes on the outside, the number you're dividing into goes on inside. And then you can sit back and you will basically repeat steps 3 through 6 or 3 through 5 over and over and over and over until you get to the end. And you know you get to the end when you can't multiply your outside to make it look like the inside, as in step number 3. Step number 3 says, what will make the leading term? So you've got to ask yourself, what will make the leading term of the divisor, the thing on the outside, the same as the leading term of the dividend on the inside? And whatever that is, you place on top of the correct column. You now take that answer that you said, hey, this is what it needs, and you multiply it to the divisor, placing it underneath, now, the dividend. And you subtract. This is the key, guys. You always need to subtract. But sometimes you subtract a positive, which is fine. But sometimes you subtract a negative, which means you actually add. You bring everything down when you subtract, anything that was not affected, and you repeat. You repeat it until you've placed a number in the constant column. At that point, you are done. The leftovers are the remainders. And you add it over the divisor at the end. Those are the 7 steps. Again, until we start doing a problem, there's just a bunch of words right now. So the example that we have today is divide x cubed minus 2, we call the dividend, by x minus 1, we call the divisor. On the bottom, it says there are 2 ways of writing the answer, because there are. Okay? We'll get to that at the very end, obviously. Now, what does this mean? I have to have standard form, number 1. Technically, are they both in standard form? Yes, highest to lowest degree. That's fine. Now, the dividend, the one that I'm dividing into, are all the degrees there from the highest to its lowest? No. So when I go to place this inside my division bar, I need to place the placeholders. So what does this mean? It means that I will have x minus 1 dividing into x cubed. What's missing? X squared, so I have 0 of them. I'm also missing 0 x's minus 2. Is everybody okay with that? I just put placeholders in. That's just setting it up. Now that we got it set up, now we can go to step 3. Step 3 says, you need to ask yourself, how do I make an x become an x cubed? Multiply it by x squared. Guess what? It's an x squared. So where am I going to place it? Above the x squared column. I am going to keep all of my x cubes in this column, all of my x squareds in this column, the x's, and so forth. Okay? Make sure we're doing that. Step 4 says take that answer and multiply it to the divisor. X times x cubed is, or x times x squared, sorry, is x cubed. And x times negative 1 is negative x squared. Step 5, I think, said you subtract. When I subtract an x cubed from an x cubed, what will happen? They go away. Guys, we engineered that to happen. It should always happen. But now you got to keep subtracting. And now I'm taking 0 minus a negative x squared. Yeah, Ellie.
Why?
And so now you're subtracting, but now we're subtracting 0 x squared minus a negative x squared, which actually is adding. So you end up with a positive x squared. At this point, after you're done your subtraction, I want you to bring the rest of it that we have not used along for the ride. We did not use the 0x and a minus 2. I'm going to try to keep everything again in a nice, neat column. It's going to make your life a lot easier. I also see when we do these, there's a lot of students who want to take the answers that we start writing up here, and they want to start it right away. They want to put it right in the front. No, keep everything in its column. At the end, we can put things together if we need to. Guess what? It's rinse and repeat, just like our morning routine with our shampoo. So, how do I make an x? An x squared. Multiply it by x. It happens to be a positive x, right? So now we multiply by positive x, and we do this again. X times x, x squared. X times negative 1, negative x. What am I going to do? Subtract. X squared minus x squared. Gone. 0x minus a negative x. It's positive x minus 2. And then I do it again. The x is because there's 0x minus a negative x. Can't cancel if there's nothing with something. We're not multiplying, we're adding, or subtracting.
Because there's no term. It's just x cubed minus 2.
One last time. I know it's one last time because there's only a constant column left. What does it take to change an x to an x? Multiply it by 1. And it happens to be a positive 1. Sometimes it could be negatives. And 1 times x, x. 1 times negative 1, negative 1. And I always like to, guys, write subtract, subtract, subtract. Because that way, in my mind, I am not going to forget. X minus x, gone. Negative 2 minus a negative 1. It's negative 1. Guess what? I'm done for 2 reasons. I'm done because I have the constant column filled out. Okay? Or I can say I'm done because I can't make an x look like a -1 without dividing. I only want to multiply, okay? Multiplying by non-fractional, like reciprocal x's and stuff like that. Because I could obviously multiply that by -1 over x, but I don't want that. So I only want to multiply by positive exponents, stuff like that. And I can't do that anymore. Now, back in the day, when we were doing this with numbers, you guys would have came up here and put r -1. Don't write that down. But you guys remember that? Remainder -1. Remainder 5. Those type of things. We're not going to do that today. We're going to do things a little bit differently because we are talking about dividing and having polynomials and all of these different things. Is that really what happens is that it's really plus -1 over x minus 1. So the answer to our problem is x squared plus x plus 1. Now we could do this as plus -1 or minus a positive 1. I'll just keep it like this so we can see the actual numbers that we have. That's the answer. Now, how do I know if this is an answer? The coolest thing about it is if I'm dividing something by something else, I can get my original answer by multiplying the pieces back together, right? So, again, we're not going to show all of this fancy work because this fancy work would actually work. I could multiply everything by x minus 1. If I actually distributed, right, boom, 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 I would end up with the answer that is back in here, x cubed minus 2. You don't need to write that down. Okay, guys, so this was our answer in the red. I'm going to put this back to what we had. Okay, so our answer there is in the red. That's one way of showing our answer. Now, if you were to look in the book, they actually may have actually put parentheses around that answer. The answer, guys, is called the quotient. So you have your divisor on the outside, your dividend on the inside, your quotient is the answer top part, and the -1 is your remainder. So the other option that they actually will take is they will multiply because they don't like having maybe some fractions in there. And so the other option is, if I put parentheses around that, is kind of like getting rid of the denominators. And so what they do is saying that if I take x minus 1 times x squared plus x plus 1 minus the 1 at the end, or plus the -1, those are the same thing. Basically, I multiply both of them by x minus 1. Essentially, if I had to distribute the x minus 1 to both of those, I would end up with that before I would do my actual multiplication. So both of those, if you looked in the back of the book, you just need to realize which one is your divisor, which one is your remainder, so that you would know which of the quotient is the answer that you probably would found, or what the answer you had up top. Okay, the last one here is just trying to show you that setup where they have d of x, q of x, r of x is equal to p of x, where p of x and d of x are all polynomials. D of x can't equal 0 because that's your divisor. Q of x is your quotient. R of x is your remainder. And so just putting in words there, all the different places that I said it was, so you guys can make the connection about which piece was what. I'm not going to necessarily read that. Homework then is the long division worksheet. Have a great day.